Hello guys, today I'm going to do a International GCSE Physics Paper 1 with the code 9203/1. This is the specimen material for the board Oxford International AQA examinations, okay? So it's a 1 hour 30 minutes paper. I'm going to try to do this as fast as possible, okay? So the materials that we need is you should have a ruler, a calculator, use black ink. Okay, this is important thing. Total mark for the paper is 90. So let's start with the first question. So a skydiver jumps from an aircraft and after 25 seconds reaches a maximum velocity of 50 meters per second. They then fall for a further 200 seconds before opening their parachute. What is the maximum velocity called? Now this is some key terminology that we have to understand is that after the skydiver jumps, the time he takes to jump after is 25 seconds. His velocity is 50 meters per second, and before opening the parachute, the time in seconds is 200 seconds. Okay, so the maximum velocity, it's going to be called terminal velocity. Okay, where both the forces become equivalent to each other. How many meters did the skydiver fall at the maximum velocity before opening his parachute? So they're asking us the distance, right? So there's a formula called distance. Distance is equal to speed times time, where time is in seconds, speed is in meters per second, and distance is in meters. As you can see, everything is in meters, okay? So speed, what's the speed given to us? It is given to us as 50 meters from the above question here. Now the time. Remember, we have to consider the time before opening his parachute, and that is given to us as 200 seconds, right? So we do not consider the time after, okay? Remember, that's a crucial point there for 1 mark. So all you need to do is 50 times 200. That should give you about 10,000 meters. And you just put a tick there. The skydiver's weight was 784 newtons. The gravitational field strength is 9.8 newtons per kilogram. Calculate the mass of the skydiver. There's another formula where weight is equal to the mass times the gravitational field strength. Gravitational field strength is in newtons per kilogram. Mass is in kilograms. Weight is in newtons. The mass, we're going to rearrange this formula to get mass is equal to weight divided by gravitational field strength, which shows us that weight here is 784 newtons divided by 9.8 newtons per kilogram. Okay, so now after understanding that, we have to find out the mass, which is 80 kilograms. So the mass here is 80 kilograms. Okay, next question. Immediately after leaving the aircraft, the skydiver's acceleration was 9.8 meters per second squared. State what happens to the skydiver's acceleration as their velocity increases. As the velocity increases, the acceleration will indirectly decrease. This is because of air resistance. There is nothing else to that. So explain your answer to 1.4 in terms of forces. Just like I said, the air resistance, right? You can say the air resistance increases, leading to the resultant force, to decrease as well. There you go. You score 2 marks for mentioning air resistance increases and another mark for saying the resultant force decreases. Now, what is the acceleration of a skydiver after he has been falling for 25 seconds? The acceleration is 0. This is because, like I said in the beginning, is that both these forces, the drag and the force that's lifting it up, that's the air resistance, which is the drag, along with the weight, they are both equivalent. These forces become equivalent to each other. The air resistance is equal to the weight. So how do you illustrate this? If I show you that this is a skydiver, the air resistance is a force acting upwards, okay? That's the air resistance. The weight is a force that's acting downwards. So they both become equivalent to each other. So that's 1 mark. So resulting when 2 forces are equal, the resultant force is, they cancel out each other. So they're basically, the resultant force is 0. So that's 2 marks where air resistance is equal to weight and the resultant force is 0. Okay? Right, so now which of the following sentences gives the best description of an object center of mass. Now, an object center of mass could be the point that's representing the mean position of matter in an object, okay? These all cross out because it's not the symmetry, it's not the weight, it's matter, okay? It's object center of mass. Now, the object below shows a thin lamina. Draw the lines on the object to find the center of mass of the thin lamina. So now, in order to do this, what you have to draw is some good straight lines. Draw a line of symmetry here, splitting the triangle into two halves. A line of symmetry there, and a line of symmetry there. This should be somewhat the point, center of mass. You just draw these lines. I think just by drawing the lines you get 1 mark. Okay. Simple errors can be used to multiply. Which of the following simple errors helps to multiply the force? Again, this is content learning, so not much into detail. Calculate the anti-clockwise moments. Sorry guys. Okay, so anti-clockwise moments are somewhat to the left, and this is representing clockwise. This is anti-clockwise, okay? So anti-clockwise moment, we have a formula where moment is equal to force times perpendicular distance from the pivot. So the force here is 560 newtons times the distance, that's 1.7 meters. That should give you about 560 times 1.7 meters, that's about 952 newton meters. Okay, this is 952 newton meters, okay? You can just leave it as 950 if you're doing two significant figures, okay, for 2 marks. Next one is that it shows another child sitting at the opposite end of the seesaw. Their weight is 420 newtons. The seesaw is not balanced, so that means the forces are not equivalent to each other. In which direction will the seesaw rotate? Okay, seesaw rotates, so give a reason. So direction, right? Their weight is 420 newtons. So we have to understand which direction will it. You know the anti-clockwise is 952 newton meters, right? From we calculated it above, right? And this is 420 newtons. Their weight is 420 newtons. So that means 420 newtons times 2.4 meters for the clockwise direction. That should be about 1,008 newton meters. So of course this is a larger force, so the seesaw will rotate clockwise, right? So we'll go in the clockwise direction. That is because you can say that the child A's momentum, they'll rotate clockwise because child A's momentum is, now the reason is because due to the weight distribution, child A will go up and child B will go down, right? So the child having the momentum, child's A moment is greater than child B. Okay, so child A. Okay, calculate how far from the pivot the child A must sit. Now we have to clearly understand this. Assume that child B does not move. Okay, so child B does not move at all. So we clearly can understand this by using the formula W1D1 is equal to W2D2. This is showing the clockwise rotation, and this is showing the anti-clockwise rotation, okay? So something that is coming anti-clockwise would be 560 newtons multiplied by, this is because we are taking it from the question above, we know that this child's weight is 560 newtons, right? So 560 newtons times the distance that the child is not going to move is equivalent to the distance of the clockwise rotation. That's 2.4 times 420. So that is about 560 newtons times distance is about, let's say, 1008 Newton meter. This is something that we calculated above, and distance is equal to 1008 Newton meter divided by 560 newtons. They eventually cancel off each other to give us the value of distance to be 1.8 meters. This is your answer, so it's going to be 1.8 meters. Now Figure 3, next question. Figure 3 shows rays of light entering a child's eye and being focused at a point. This point is not on the retina, so the child sees a blurred image. What is the visual defect of this eye? It is short-sightedness, okay? This is content learning again. You have to remember these information. What the cause of the defect is because the lens is unable to focus the rays onto the retina. And the lens that is used to correct this visual defect is diverging lenses. Okay, we use diverging lenses. Sorry. Now, state the name given to the concentrated source of light used in eye surgery. Okay, this is a concentrated source of light. Nowadays, laser treatment is being used to fix eyes, where they do certain procedures in order to fix the eye. Okay, next question. The diagram shows how a converging lens forms an image of an object. Describe the nature of this image. So this is the image. What are the things we can see by comparing this image with the object? So we can see that the image it's upright. That's what we know, it's upright. And since this appears on the same side of the lens, it's virtual, right? It's upright, it's virtual, and it's magnified. It means it's enlarged. It's way bigger, magnified. It's magnified than the object, and magnified than the object. Or you could say, bigger than the object. Okay, bigger than the object. This is supposed to be a comma. Bigger than the object. Okay, the image is bigger than the object, so it's magnified. But the keywords here for 3 marks are upright, virtual, and magnified. Calculate the magnification produced by the lens. Okay, so the height and the object are drawn to scale. Now, what you have to do for this question is to remember a formula of magnification. Magnification is equal to the image height divided by the object height. Okay, so the image height divided by the object height. So by just guessing, if you use the scale, if you use a ruler to measure the height of the image, it should be approximately 3.1, right? And for the object, I think it should be 1 based on the scale. Or you could just do the other way around. There are many ways to do this question. So 3.1, I'm going to leave it as 3.1. You can use concepts but the answer is in the range 3.0 to 3.1. Okay, so now what is the name given to the point labeled F in the diagram? So what is this point here labeled F? What does F represent? F is the principal focus, okay? It's not the focal length, remember, it's the principal focus. That's 1 mark, is content learning again, principal focus. Next one, what are the differences between waves A and B? Okay, so we can just refer to one wave and compare it against the other wave. So we can see, based on the frequency, is that the frequency for B is greater. For B's frequency is greater, right? You can see that there are more frequencies. Wavelength, okay, the distance, okay, you can see that B's wavelength is shorter than that too of A, so wavelength is shorter. And the amplitude, we can see that B's amplitude is higher, okay? So you can say the frequency for B is greater than A, the B's wavelength is shorter than wave A, B's amplitude is higher than wave A. Radio waves are electromagnetic waves. Describe how radio waves are different from sound waves. Now you can compare by stating points of sound waves and compare them with radio waves. Okay, so main thing if we can say that is that radio waves, right? Radio waves are transverse. So radio waves are transverse waves, okay? Transverse waves, while you can compare it to sound waves, while sound waves are longitudinal. So there you go, that's 1 mark. Longitudinal. Actually, that's 2 marks because you're stating what radio waves are and stating what sound waves are. So that's already 2 marks given to you. All you need to do is that radio waves, you can say that radio waves travel, I'm just writing it quickly guys, travel at speed of light, and sound waves are slower than electromagnetic waves, and EM waves. You can just call them electromagnetic waves, EM waves. And radio waves, you can say that they have greater frequencies. Well, actually, you can highlight they have greater frequencies, but you can say that radio waves can also travel through a vacuum, whereas you can write there, whereas sound waves need particles to travel through. So now this is some good 4 marks being scored. When a racing car passes an observer, the pitch of the sound of the engine appears to change. State the name of this effect. It's called the Doppler effect. This is some content learning as well. Describe how the observed frequency of the sound changes as the car travels towards and away from the observer. So how this works is, as the car moves closer, right, moves closer to the observer, the frequency should increase. Frequency of the sound increases, rises, increases is a better one. And while the car moves away from the observer, the frequency of sound decreases. Okay, so there you go, you scored that mark. Now draw 4 lines between the boxes to complete the sentences. One sentence has already been completed. Current through a resistor depends on the potential difference across the resistor. A direct current, remember, direct current is a current that is supplied by the battery. In series circuit, the potential difference is always shared. Okay, the current is always same in the series circuit, while the potential difference is shared. And alternating current is something that's constantly changing direction. And in parallel circuit, the potential difference is across each component is the same, whereas the current is shared in a parallel circuit, but the potential difference is the same. What is meant by an electric current? Now, electric current, there's only one definition. Okay, electric current is the rate of flow of electric charge. There you go. Electric current is the rate of flow of electric charge. Next one, the graph shows the electric current through a 12 volts filament bulb varies with the potential difference across the bulb. Explain why the resistance of the metal filament inside the bulb changes as the potential difference across the bulb increases. Okay, so now why the resistance changes. So as I'm just going to say PD is potential difference. As the PD increases, as the potential difference increases, the current increases as well. The current increases in the metal filament. Okay, right, in the metal filament. Next one. And this one, it will indirectly increase the number of chances of collisions, right? So collisions increases, you can say collisions increases between atoms in the wire, which will cause ions to vibrate, more, which will increase the vibration of the ions, thus increasing the temperature, indirectly the temperature of the metal filament. There you go, there is 3 marks scored for that one. What is the component? So this is a diode. Remember the graphs for diode, filament, lamp, and resistor. Okay, so for diode, this is the graph. Next one, calculate the resistance of the component with the potential difference across it to be about 0.8 volts. Okay, so we have to understand this. Use data from the graph. So we're going to use the formula where the volts, right, where resistance is equal to voltage divided by the current. Potential difference divided by current, where current is amps, potential difference is volts, resistance is ohms. So the resistance is going to be equivalent to the voltage is already given to us as 0.8 volts, and the current should be about 0.05 assumption. So let's check it out where the voltage is and where 0.8 might lie. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0.5 divided by 10, that should give us about 0.05. So 0.05 plus 0.05, that should give us about 0.55 plus again 0.05, 0.06, this is 0.06, 0.07, 0.08. So this is 0.08 volts, should lead to approximately, you can see the halving actually going all the way there to 0.05 amps. So you can just put it 0.05 amps, right? And that should give you about 0.8 divided by 0.05 amps. That's about 16 ohms. 16 ohms. There you go, you scored that 2 marks. Next one, the diagram shows a structure of the cable. The cable is part of an air conditioning circuit. Inside an air conditioner, the cable is connected to the mains electricity supply through a residual current circuit breaker RCCB. If the cable is accidentally cut, the RCCB automatically switches the circuit off. Explain what happens when the cable is cut to cause the RCCB to switch the current off. So explain what happens, okay, when the cable is cut to cause the RCCB to switch the circuit. So you can say that some current flows through the copper braid, right? Some current flows through copper braid, and we can say that, and the RCCB, it detects difference between the current in live and neutral wire. So this is the answer that you should write and learn, in live and neutral wire. Okay, there you go. Next one, the circuit. The circuit can be also switched off by the action of the fuse. Give one advantage of using a RCCB to switch off a circuit rather than a fuse. So it's faster acting, or you could say it can be reset quickly. Okay, so there's one way of saying that. So 230 volts main electricity supply causes a current of 11 amps to flow through the cable. Calculate the amount of charge that flows through the cable when the cable is switched on for 2 hours. So you have to use the formula where the charge flow is equal to the current times the time in seconds, current in amps, charge flow in coulombs. Okay, so we have 1 hour is equal to 3,600 seconds. So 2 hours, you just multiply those two values together. 2 times 3600 is equal to 7,200 seconds. So the charge flow is, the amps that are given to us is 11 amps times 7,200 seconds is equal to 79,200 coulombs. 79,200 coulombs, unit is coulombs C, or you could just write coulombs for short. Coulombs, right? Yeah, correct. So you have coulombs there, and it can be rounded again to 2 significant figures. Mostly it can be 79,000, okay? But I'm just going to leave it as 79,200. Calculate the energy transfer from the cable to the air conditioner in 2 hours. So this is very important that you use that the energy transferred is equal to the coulombs, to the charge flow multiplied by the potential difference in volts. So the energy transferred is in joules, coulomb charge is charge flow is in coulombs. Okay, so the energy is equal to 79,200 times the volt is given to us as 230 volts. That should give us approximately, let's say, 18216,000 joules. 18216,000 joules. Now you can either multiply 79,000 times 230 volts to get your answer, so that's also fine. Okay, and you can also leave this in standard form if you like, or convert this as well to kilojoules. It's allowed in the marking scheme. Okay, cooling circuit includes a thermistor. So the thermistor is located in the room and acts as a thermostat to control the temperature of the room. Describe how an increase in the temperature of the room affects the thermistor. So as the temperature, okay, that's temperature increases, as the temperature increases, so basically the temperature increases, let's say the increase in temp, right, increases the temperature. The increase basically, actually just cut that out. How the increase in the temperature affects the thermistor. Okay, let's understand this. It increases the temperature of the thermistor, as well as change the resistance, of thermistor. Okay, change the resistance of the thermistor as well. Okay, next question. Right, so now nuclear fusion takes place within a nuclear reactor. This is pretty important that you understand this. It takes place within a nuclear reactor. Nuclear fusion takes place within a star. Say one way in which the process of nuclear fusion differs from the process of nuclear fission. So the nuclear are joined together in nuclear fusion and not split. That's one mark for getting that answer right. Describe the process of nuclear fission of uranium-235. Use the information in the equation. So as you can see, there's a neutron absorbed by you. You can see that it's absorbed, it's added to you, and it forms a larger nucleus. And this larger nucleus is always unstable. This larger nucleus is unstable. Okay, it's unstable, and the larger nucleus splits into two more. The larger nucleus splits into two smaller nuclei. So let's see how many points we have written. 1, 2, 3, 4. So there are 4 points. You can also mention that it releases 3 neutrons and energy as well. Okay, so an isotope of barium is Ba139, and Ba139 decays by beta decay to lanthanum 139 to complete the nuclear equation that represents the decay of Ba. So this is beta decay. So the symbol is 0 with the symbol of B minus 1, and Ba, as mentioned, maybe a periodic table is given. Always check the atomic structure. It's 56, and this should be 56. So what can be added, okay, to make 56? You have to either add 56 plus 1. That should give us 57. So 57 plus minus 1 is 56. So it's correct. So there you go. 3 marks scored by just writing 57, 56. minus 1b. Okay. Scientists have observed spectra from different galaxies. Take one box to complete the sentence. These observations have proved the Big Bang Theory. Proved the existence. Okay, now proved evidence that the universe will expand forever. Proved more evidence to support the Big Bang Theory. That's more likely to be the observation. Provided more evidence to support the Big Bang Theory. Now, the net result of the nuclear fusion reaction shows that there's a loss of 0.7% mass, and the energy. They've given us a formula as well to calculate. So your first thing to do is to always calculate the energy released when 1 gram of hydrogen fuses to form helium. 1 kg is equal to 1,000 grams. Because mass is in kilograms, you have to convert the grams to kilograms. So 1 divided by 1,000 should be about, 1 divided by 1,000 should give us about 1 times 10 raised to the power minus 3 kilograms. Now remember, there's a loss of mass of 0.7%. So you have 0.7% multiplied by, put in brackets, 1 times 10 raised to the power minus 3 kilograms. That should give us about, just put that in your calculator and it should give you an approximate answer, or you can calculate it physically, it depends on your choices. So it should give us about 7 times 10 raised to the power minus 6. 7 times 10 raised to the power minus 6 kilograms. Now we have a formula for energy release is equal to loss of mass times the speed of light squared. So the loss of mass here is 7 times 10 raised to the power minus 6 multiplied by the speed of light, which is given to us as 3 times 10 raised to the power 8 all squared. Remember, now by typing this, by putting this in the calculator, you should be multiplying both these values, all placed in brackets, okay, because it's easier to do that. And you should be getting about 6.3 times 10 raised to the power 11 joules. 6.3 times 10 raised to the power 11 joules. Just leave it as it is, as a standard form. 6.3 times 10 raised to the power 11 joules. Okay, next one. Okay, so the table shows the lifetimes of surface temperatures of main sequence stars with different masses. Okay, so what conclusions can be drawn from the data given in the table? So we can analyze here as the mass increases, right? In million years, you have increase in mass. You can say greater mass. Okay, greater mass means greater core temperatures, okay, because the temperatures keep increasing. Greater core temperatures and increasing mass, okay, actually you should say greater core temperatures. Connect this with greater core temperatures means, right, greater rate of fusion. That's it, just for 2 marks, greater rate of fusion. So because there is a greater core temperature, so greater mass means greater core temperature, it indirectly means that there's a greater rate of fusion. Okay, so the next question, the diagram drawn below places stars in one of 4 groups. Okay, the sun will spend most of its life cycle as a main sequence star. This is a stable period. Describe using the diagram what will happen to the temperature and luminosity of the sun after the stable period. And so now looking at the graph, looking at the graph, what you have to understand in the diagram is that as the temperature decreases, goes down, as the temperature decreases, right, as it changes to a red giant. As it changes to a red giant, right? As the temperature increases, it changes to a red giant. As the temp increases, as the temperature increases, or you could say the luminosity increases, it changes to a white dwarf. Right? We have to describe using specific. Okay, so there's a change in temperature. There's a change in temperature of the sun as the sun changes to a red giant, and then to a white dwarf. You can also include any calculations here, but sun with a relatively luminosity of 1 should give us an idea what's happening here, but you can just say that it changes to a red giant and then to a white dwarf, right? Okay, that should gain 1 mark as well. So there you go, 3 marks scored. Next one, let's understand the diagram shows a microphone being used to detect the output from a loudspeaker. The oscilloscope shows the wave pattern produced by the loudspeaker. How many waves are produced by the loudspeaker in 0.000 seconds? Now here I'm just going to use a different color ink. So how many waves are being produced? You can see there's 1, there's 2, and there are 3 waves being produced. There are 3 waves. This is a wave, okay? There are 3 waves being produced here. Okay, there are 3 waves being produced. how many waves are produced by the loudspeaker every second, right? Every 1 second. So we know that in every 1 second, how many waves are being produced. How do we calculate this? So we know that there are 3 waves being produced in 0.0001 seconds. So how many waves are being produced in 1 second? It is basically 3 divided by 0.0001 seconds is equal to 30,000 waves being produced. 30,000 waves being produced. Now explain why a person with normal hearing cannot hear the sound being produced by the loudspeaker. Okay, why they cannot hear? Because the frequency, right? The frequency is 30,000. Frequency is 30,000 hertz. Now, how do I know it's 30,000 hertz? You need to remember that 1 hertz is equal to 1 wave per second. So I just converted 30,000 waves to hertz by just multiplying it by 1 hertz. So it's indirectly 30,000 hertz. While the range, right? Well, the range of human hearing is between 20,000 hertz to it is between 20 hertz to 20,000 hertz. So indirectly it's just meaning that 30,000 hertz is greater than the human range of hearing, and that's about maximum to 20,000 hertz. Okay, so that's why a normal person with normal hearing cannot hear the sound produced by the loudspeaker. Now explain what happens to produce pulse A and pulse B. So first of all, you have to say it shows us the diagram shows a high frequency wave and used to check internal cracks. This should tell us that this is an ultrasound wave. The ultrasound that is being reflected is being reflected, right? And pulse A shows crack, while pulse B, right? Well, pulse B shows back of the block, back of the crack. Okay, so pulse A is the crack, while pulse B, it indicates the back of the block or the crack. Okay, calculate the distance from the head of the bolt to the internal crack. Use the information. So distance is dst. We have to understand how to calculate this. Okay, so the time. So we know that 1 cm represents 0.0000005 seconds. Okay, so how many square blocks are there? 1, 2, 3, 4, 5. So we know that time, this is what I think they mean by time. I'm not sure what this 2WO means, but I think just leave it there. So time is equal to 0.000005 seconds multiplied by 5 squares. That should give you about 0.0000. How many zeros is it? 1, 2, 3, 4, 5. There are about 5 zeros multiplied by 5. It should give you about 2.5 times 10 raised to the power minus 5 seconds. Okay, that's given the time. We're given the speed. The distance is just equal to 2.5 times 10 raised to the power minus 5. Actually it's not that. You don't have to write that. First we write the speed down for 6,000 meters a second times 2.5 times 10 raised to the power minus 5 seconds. Put them in brackets. So 6,000 times brackets 2.5 times 10 raised to the power minus 5. That's about, the distance is about 0.15 meters, and you just write 0.15 meters. Okay, let's move on to, actually the questions are over. There seems to be no questions. Okay, great. So now we have just completed the specimen material for the OxfordAQA paper 1. Okay, so just comment, if you enjoyed the video, please like, share, and subscribe.